All right, we are beginning chapter 10.2. Today's lesson is arithmetic sequences and series. All right, a sequence whose consecutive terms have a common difference is called an arithmetic sequence. That common difference is the difference between the terms. So question number one, find the next three terms in this sequence. So -5, 7, 19, etc. Okay, the trick is to figure out what is the pattern. What is that common difference? If it is an arithmetic sequence, and it is. And the way we find it, that common difference, take any term minus the one before it. So in other words, we could say 7 minus the term before it, a -5. So 7 minus a -5 would get us a common difference of 12. Now we could have also done the 19 minus the term before it. Also gets us that same answer 12, which it will if it's an arithmetic sequence. So the common difference is simply 12. So how do you find the next three terms? Well, you take 19 and you add 12 to it. So we get 31. Add 12 to it. We get 43. Add 12 to it. 55. And there's your next three terms to the sequence. All right. Next. This normally works better as a classroom interactions thing, but we're just going to fake it. Here we have a sequence, and I'm trying to develop basically a formula, show you where the formula comes from. So we call this our first term, second term, third term, fourth term, fifth term, sixth term, etc. Okay, 7, 10, 13, 16, 19, 22. The common difference here is 3. Now, going back, we could also look at this as the first term is just 7. The second term is the 7 plus 3. Now, the third term, go back to the beginning, gets that first term 7, but now plus 2 groups of 3. The fourth term is 7 plus 3 groups of 3, etc., etc. So all the way down to, if I were to jump all the way to the 10th term, how would I figure out what the 10th term is? Well, it would be 7 plus 9 of those 3's, following that same pattern. Okay, that leads us to the formula for the nth term of an arithmetic sequence. So the nth term of an arithmetic sequence is simply the first term, which was the 7 in what we were doing here, plus n minus 1 times that common difference. Common difference being 3 up here, and let's say for the 10th term we only wanted 9, one less. But that's your formula. You need to have that formula memorized. Okay, it is the formula for the nth term of an arithmetic sequence. So number 2, find the 25th term in this sequence. Now, just to be clear, you could do what we did up here in question number 1 and count 25 times and find that 25th term. If you do that, I will count the answer wrong. Okay, the point of this question is the next 3 terms is perfectly fine to count it. The point of question number 2 is, do you know this formula? So we want to go straight to the answer using the formula. So that's what you have to show me if you want to get credit. So find the 25th term of this sequence. Okay, first need to recognize the first term of the sequence is 12. Common difference is -6, and I got that by doing 6 minus 12, or 0 minus 6, any term minus the previous term. So my common difference is -6. Okay, formula. We just said it. The nth term will equal the first term plus n minus 1 times that common difference. In this case, we are looking for the 25th term. So I want a subscript 25. So the 25th term will be the first term plus 25 minus 1 times that common difference. That's basically what we're looking at. All right, so first term is 12. Common difference is negative 6. And we are just doing this arithmetic. All right, 24 times negative 6 is basically 12 times 12. So negative 144. So we find out that the 25th term of this arithmetic sequence is negative 132. All right. Next, find both an explicit formula and a recursive formula for the nth term of the arithmetic sequence that is shown. Okay, for starters, they already told us it is an arithmetic sequence. First term is 12. Common difference here would be 21 minus 12, 30 minus 21, whatever you do, you should get an answer of 9. Now, based on the formula we were just talking about, the nth term of an arithmetic sequence we get this formula. Now, knowing that our first term was 12, and now our common difference is 9. Clean up the algebra here. So I'm going to distribute that 9 throughout the parentheses. So I get 9 in. So just cleaning all of this up, we should end up with the nth term being 9n plus 3. All right, that is the explicit formula. Now, recursive, okay, this goes back a lesson or two. Talking about your recursive formulas. Okay, first off, for recursive, you've got to have something that you're starting with. So in this case, what we're starting with is our first term. First term is 12. And this is be pretty straightforward. Now, generally speaking, how do we get the next term? Well, I'm going to just do it this way. That nth term will always be the term right before it plus whatever that common difference is. In this case, once again, what is the common difference? The common difference is 9. So really, our answer to this problem starts with this. First term is 12, and then saying the nth term is the term right before it, plus 9. Now, collectively, it takes both of those. That is your recursive formula, because you do have to have that first part. All right, I don't know if the book's going to make you do a lot of that or not, honestly. I don't do too much with that. I tend to stick more with that formula for the nth term. All right, number 4, basically the same idea, but they give us something different in the formula. They give us the 31st term, and we're looking for the first term. Okay, still using this formula for the nth term of an arithmetic sequence. And this problem actually doesn't tell us it's arithmetic, but it's arithmetic. That's the section we're in. All right. So this time, though, what they give us is the 31st term. So n is 31. The first term, we don't know what that is, but that is what we are actually looking for. And they do tell us that the common difference is 10. And they do tell us that 31st term is 197. And now it's just a straight up algebraic equation. Solve for your variable. Solve for the unknown. Question 5 is going to build on what we did with question number 4. Write an arithmetic sequence that has 4 arithmetic means between 4.3 and 12.8. 4 arithmetic means just means there's 4 numbers between those two. So in other words, what we've got is we've got 4.3, some number, some number, some number, some number, 4 of them. And then we've got 12.8 in our sequence. So in other words, we know the first term in the sequence, second, third, fourth, fifth, and we know the sixth term. That arrow has issues. So we know the first term and the sixth term. What we don't know is the common difference. Still using our same formula. But we are specifically going to now let n be 6 because we know the sixth term. So the sixth term is 12.8. Lost my decimal there, wrote over it. 12.8. First term is 4.3. In the D, the common difference is the unknown. Solve for your unknown. Now, in this case, you can count again because that's the whole point of that. We're not going to use that formula 4 times to find these 4 answers. They've already told us 4.3 is the first. So we know that's the first term in the sequence. Add your common difference of 1.7 to that. So 4.3 plus the 1.7 will get us 6. Plus the 1.7, 7.7. Plus another 1.7, 9.4. Another 1.7, 11.1. Another 1.7, 12.8. And if you do it right, there's your first term, there's your sixth term, and then these right here are your 4 arithmetic means, right? All right, write an arithmetic sequence that has 4 arithmetic means. So our answer is actually the entire sequence. Make sure you answer the question. They did not ask what the 4 arithmetic means were, they wanted the whole sequence. All right. That is a lot with the sequence. Now we're going to switch to series. Okay, we talked about this also previous lesson. The arithmetic series is the sum of the terms of the arithmetic sequence. Okay, it also has a formula, S for sum. So sum of the first n terms of the arithmetic sequence, the formula is you take n, the number of terms in the sequence, divided by 2, and multiply that by the sum of the first and the last term. A sub n being the last term. All right, so I'm going to kind of, number 6, we're going to work this problem out using the formula, but also kind of prove the formula at the same time. Find the sum of this series. All right, so first I've got, well, first recognize that it's counting by 2's. So the common difference is 2, which means it is an arithmetic sequence that's being added. Hence, it's an arithmetic series. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. So there are 10 terms in this arithmetic sequence. So the formula that we were just using from right here tells us then the sum of our first 10 terms of this sequence is going to be n over 2 times the first term, which is 1, plus the last term, which is 19. Now cleaning up that math, 10 divided by 2 gets us 5. 1 plus 19 is 20. And in this case, if we were to just quickly add all these up, we would get 100. But it's much faster using this formula than to add them up. Now, just to demonstrate where a shortcut, where the formula comes from. What is 1 plus 19? 20. 3 plus 17? 20. 5 plus 15? 20. 7 plus 13? 20. 9 plus 11? 20. So if we did that, what we had were 1, 2, 3, 4, 5 groups of 20. And I could really put any of them together, but the easiest is simply to take the first and the last. So that's where the 1 plus 19 comes from. And this part here, take the number of terms and divide by 2 because we're putting them in groups of 2. So again, that should help kind of prove where that formula comes from. But that is our shortcut. If that last term, though, is not known, how would you figure it out? Well, there actually is another formula, but it's simply derived by using the 2 formulas we already know. So we know the formula here is this for the sum of those first n terms of the arithmetic series. But if we don't know this, we do. Right here, the nth term is the first term plus n minus 1 times that common difference. So, coming back here, change this to brackets because I have other parentheses. I have a1 plus, and now for that nth term, it's simply going to be a1 plus n minus 1 times the common difference. Cleaning that up a little bit. We have like terms there, so I've got 2 a1s. And that is an extra formula. So that is a formula for if you don't know the nth term in the sequence. Me personally, I actually don't memorize it. I simply do what I just showed you right here. I have those 2 formulas memorized, and I just start from the beginning. It makes me do a couple extra steps, but to me, that's quicker and easier. Okay, but it's your choice. You can either memorize this formula if you want to or not, but it is a formula. All right, so number 7. Find the 150th partial sum of the arithmetic sequence 5, 16, 27, 38, 49, etc. Okay, so this is actually an infinite arithmetic sequence. It's going to keep going on forever and ever. The 150th partial sum means we just want the sum of those first 150 terms. So the sum of the first 150 terms will be 150 divided by 2 times, and this time I am just going to use this formula because it's right here above, right here in front of me. So it's 2 times the first term, which is 5, plus 150 minus 1. And what is our common difference? Any term minus the one before it, every single one of them should give us an answer of 11. If we don't get the same answer, either we screwed up or it is not an arithmetic sequence, in which case the formula doesn't work anyway, because it has to be an arithmetic sequence for this formula to apply. All right, and then just clean up the math. So 10 plus 149 times the 11. Nine, 4 is 13. 1 is 5 plus 1 is 6. 1. And I could do a 25's trick, but I am not going to. Numbers are too big, and I'm just going to cheat. I happen to have the answer. I'm just going to write it down for you. Alrighty. Like I said, just draw with the formula though, and the rest was just clean up the algebra. Last question, number 8. In a golf tournament, the 16 golfers with the lowest scores win cash prizes. First place receives a cash prize of $1,000. Second place receives $950. Third place receives $900, and so on. What is the total amount of prize money that is awarded? So we want the sum of these first 16. So it's going to be 16 divided by 2, and divided by 2. Again, we don't know the last term, so they're kind of making us use this last formula. We do know that the first term, or let's see, what's 1,000? There it is. Give me a second to find it. N minus 1, so 16 minus 1 is 15 times that common difference. Now, the common difference is negative 50 bucks. It's going down. And again, there's your setup. Just clean up the arithmetic. Uh, 75 with a 0. Let's see, 1 with 3 zeros and another 0. $10,000 would be the total prize amount that they award. All right. So that was 10.2, arithmetic sequences and series. Basically, there were 3 formulas. 2 are mandatory, you know. 1 kind of optional. You can memorize it if you want. Start from the beginning if you don't want to memorize it. But basically, there are 3 formulas. 1 for the nth term of the arithmetic sequence, and then there are 2 for the sum of an arithmetic series. All right. Again, that was 10.2.